At Granger, we're for the ones who specialize in saving the day and for the ones who've mastered the art of keeping business moving. We offer industrial-grade supplies for every industry with same-day pickup and next-day delivery on most orders, all backed by real people ready to help. So you can get the right answers and products right when you need them. Call, clickgranger.com, or just stop by. Granger, for the ones who get it done.
This is Space Time, Series 25, Episode 82, for broadcast on the 25th of July, 2022. Coming up on Space Time, the countdown is underway for NASA's Artemis 1 mission to the Moon, new warnings about the DART asteroid impact mission, and counting down to the death of a red giant. All that and more coming up on Space Time.
Welcome to Space Time with Stuart Gary.
The countdown is now underway for the launch of NASA's Artemis 1 mission to the Moon. NASA is looking at August the 29th as the potential launch date for the maiden flight of the massive SLS moon rocket. The unmanned mission, which will fly beyond the moon, is expected to take around 6 weeks, providing a final in-flight test for the new Orion spacecraft and deploying numerous small satellites, which will carry out a range of deep space experiments. Artemis mission manager Mike Serafin says the mission's primary goal will be a test of the Orion capsule's new heat shield under actual trans-lunar re-entry conditions. Orion will be flying at some 39,400 kilometers per hour as it returns to Earth. Its heat shield will reach temperatures of over 2,900 degrees Celsius. That's half as hot as the sun. And it means Orion will re-enter Earth's atmosphere faster and hotter than any other spacecraft. Now, if all goes according to plan with Artemis 1, it'll be followed in 2024 by Artemis 2, the first manned Orion mission. That'll take a crew of 4 on a 10-day journey around the moon and back, with the Artemis 3 mission returning people to the lunar surface slated for 2025. 53 years after Apollo 17 took the last humans to the moon. NASA says the big difference between Artemis and Apollo is that this time humans will be going to the moon to stay, providing a sustained presence there and using the lessons gained to prepare for the first manned flights to Mars in the 2030s. NASA Associate Administrator Jim Free says that at this stage the first launch window for Artemis 1 is August the 29th. They'll be followed by another window on September the 2nd and then September the 5th, depending on last-minute closeouts of tweaks and fine-tuning issues. The decision to go follows last month's successful wet dress rehearsal on the launch pad at the Kennedy Space Center in Florida on June the 20th, which achieved 90% of pre-flight test goals. The last major sticking point was a persistent liquid hydrogen leak in the cryogenic umbilical line quick disconnect plumbing to the SLS core stage, and that was resolved by simply replacing some faulty seals. During the test, mission managers simply bypassed the leak issue by closing the bleed valve in the hydrogen flow path, allowing them to work around the problem. But that wouldn't work during an actual launch because closing the bleed valve would leave the engine thermal systems without proper regulation. NASA says it'll make a final flight commitment about a week before the launch when it completes its flight readiness review of the Artemis 1 stack, including both the SLS Space Launch System and the Orion spacecraft. Right now, the Artemis 1 launch vehicle is back inside the vehicle assembly building for final inspections and modifications. These include installing the flight batteries, stowing payloads, undertaking power tests on Orion, and performing software loads on the SLS core and interim cryogenic propulsion, or ICP stage, the first and second stages of the SLS launch vehicle. Engineers have also replaced the navigation and control assembly unit, and they're checking over the ICP that'll give Orion its final burn needed to send the spacecraft onto its trans-lunar orbit. Once ground crews have completed all their upgrades, checks, and final tests inside the vehicle assembly building, the massive rocket will take what's hoped will be its final journey back out to the launch pad. And that could happen as soon as August the 18th. Now, if Orion flies during its 2-hour August 29 launch window, it'll see a 42-day mission with Orion splashing down in the Pacific Ocean on October the 10th. A September the 2nd launch window, also 2 hours, would see Orion return 39 days after launch on October the 11th, while a 1.5-hour launch window on September the 5th would see the Orion once again return 42 days later, this time on October the 17th. If all 3 launch windows are scrubbed, then NASA will move to one of several interim launch opportunities selected for mid-2023. This report from NASA TV.
3, 2, 1, 0. Ignition. Liftoff.
Artemis 1 will lift off from Launch Pad 39B at NASA's Kennedy Space Center in Florida with 8.8 million pounds of thrust, provided by the most powerful rocket in the world, our Space Launch System rocket, or SLS. The uncrewed flight will be the first integrated test of SLS, our new Orion spacecraft, and exploration ground systems at Kennedy. Artemis 1 will send Orion beyond the moon, 280,000 miles from Earth, farther than any human spacecraft has ever flown.
This is not NASA doing this. This is the United States of America doing this program, the Artemis program, and there are companies all across our country that have a part in it. So there is kind of this wave of excitement being generated just by saying, we're going back to the moon.
After the upper stage of the rocket separates from Orion, the upper stage will deploy small satellites over several days to perform science experiments and technology demonstrations. Orion will make its multi-day outbound trip to the moon, propelled by a service module provided by the European Space Agency. Engineers will test Orion's systems on the way to the moon. Then, Orion will fly about 60 miles above the lunar surface, using the moon's gravity and engines on the service module to enter a lunar orbit. After about a month and a total distance of over 1 million miles, Orion will return home, faster and hotter than any spacecraft has before. A primary goal of Artemis 1, ensure Orion safely returns to Earth before we fly with humans. When we do, we'll build our capability for sustainable lunar exploration, preparing us for missions farther into the solar system.
Initially, what we'd like to do is start establishing a presence on the moon. So we're going to establish going back there on a regular basis, and then we'll end up setting up Gateway, and we would launch to the Gateway, and from Gateway, land on the surface of the moon.
We are there for, weeks, months on end. And there, we're going to be able to test out all the hardware and the habitats and the hatches and the suits and the rovers that'll allow us to prove out those technologies. The moon will lead the way to Mars, and we should be there within the next couple of decades.
And in that report from NASA TV, we heard from NASA astronauts Reid Wiseman, Jeanette Epps, and Randy Bresnik. Interestingly, NASA's Artemis 1 press update came on the 53rd anniversary of the Apollo 11 moon landing. That was back in 1969, when Neil Armstrong and Edwin Buzz Aldrin became the first humans to walk on the surface of another world. This is Space Time. Still to come, a new study warns that NASA's DART mission could leave its target asteroid badly deformed. And astronomers have for the first time witnessed a stellar pulse that's foreshadowing the death of a star known as a red giant. All that and more still to come on Space Time. A new study warns that NASA's planned DART mission, slated for later this year, could leave its target asteroid badly deformed. The DART, or Double Asteroid Redirection Test, is the world's first full-scale planetary defense test designed to deflect a near-Earth asteroid before it can impact the Earth by slamming a spacecraft into it with enough force to change the space rock's trajectory. However, new computer simulations have suggested that instead of leaving behind a relatively small crater, the impact event could leave the asteroid near unrecognizable. 66 million years ago, a giant asteroid impact on the Earth in what is now Mexico's Yucatan Peninsula caused a mass extinction event which killed off 75% of all life on the planet, including all the non-avian dinosaurs. The problem isn't that it could happen again, but that without question it will. It's just a question of when. And then it becomes a question of how prepared we are. The good news is that currently no known asteroid poses an immediate threat to Earth of this nature. But if one day a large asteroid were to be discovered on a collision course with the Earth, it might have to be deflected from its trajectory in order to prevent a catastrophic collision. The DART spacecraft was launched last November on a mission to undertake the first full-scale experiment on a deflection maneuver. DART's mission is to collide with an asteroid and in the process hopefully deflect it from its current orbit onto a new path, in order to provide valuable information for the eventual development of a planetary-wide defense system. The target will be the near-Earth asteroid Dimorphos, discovered in 2003. Originally called Didymoon, the 170-metre-wide space rock orbits a 780-metre-wide Apollo group asteroid called 65803 Didymos in a synchronous binary system. The impact event will take place between September the 26th and October the 1st this year. As the collision occurs, a flyby mini-satellite named Lycia Cube, provided by the Italian Space Agency, will image the event. And later on, the European Space Agency's Hera mission will observe the asteroid after the impact to see what really happened. However, a new report in the Planetary Science Journal suggests the impact may deform Dimorphos far more severely than previously thought. The study's lead author, Sabina Radican from the University of Bern, says that contrary to what one may imagine when picturing an asteroid, evidence from the Japan Hayabusa mission shows that some asteroids can have very loose internal structures, more like rubble piles than solid rock. These rubble piles are only held together by gravitational interactions at small cohesive forces. She says previous simulations of the DART mission impact almost always assumed a much more solid interior for Dimorphos. A rubble pile structure could drastically change the outcome of the collision. Radican warns that instead of leaving a relatively small crater, DART's impact at a speed of around 24,000 kilometers per hour would completely deform Dimorphos. The asteroid could also be deflected much more strongly, with far larger amounts of debris ejected from the impact than previous estimates had predicted. Radican says one of the reasons the scenario of a loose rubble pile structure hasn't been thoroughly investigated before is simply because the necessary methods to carry out such a study weren't available. These sorts of impact collisions can be recreated in laboratory experiments, and the relatively long and complex process of crater formation following such an impact, a matter of hours in the case of DART, make it impossible to realistically simulate these impact processes up until now. However, her new modelling approach, which takes into account the propagation of the shock waves, as well as the compaction and subsequent flow of material, has allowed her for the first time model the entire cratering process resulting from impacts on small asteroids like Dimorphos. This is Space Time. Still to come, counting down to the death of a red giant, and later in the science report, the latest State of the Environment report, painting a dire picture of climate inaction in Australia. All that and more still to come on Space Time. Astronomers have for the first time witnessed a rare dynamic event foreshadowing the death of a star known as a red giant. They've seen spectacular pulsations in the star, causing it to dramatically change size, brightness and temperature. The doomed star, Ursa Minoris, which has about twice the mass of the Sun, is located some 3,000 light-years away in the constellation of Ursa Minor, the Little Bear. Ursa Minoris has been monitored closely since 1905. Until 1979, its brightness had varied over a period of 310 to 315 days. However, from 1979, its period decreased suddenly to 274 days, and now appears to be decreasing by around 2.75 days per cycle. The study's authors have been observing the star as it diminishes in size, brightness and temperature over the past 30 years. The latest death throes, reported in the Astrophysical Journal and on the pre-press physics website archive.org, reinforces predictions about our own sun's ultimate fate. Tiursa Minoris was born about 1.2 billion years ago. And over the past few million years, during its last stages of life, the red giant's been undergoing a series of pulsations whereby its size, brightness and temperature have fluctuated wildly. Now, energy production in Tiursa Minoris has become unstable. During this phase, nuclear fusion flares up deep inside, causing thermal pulses. And these pulses cause drastic, rapid changes in the size and brightness of the star, which are detected over centuries. One of the study's lead authors, Dr. Meredith Joyce from the Australian National University, says it's a rare opportunity to observe the signs of stellar aging over a human timescale. Joyce anticipates that Tiursa Minoris, and our own sun for that matter, will both end their lives relatively quietly and slowly, more of a whimper than the massive explosions caused by larger, more massive stars going supernova. She says the observations support the hypothesis that our sun too will eventually turn into a red giant, ultimately losing its outer envelope as an ever-expanding glowing ring-shaped shell of gas called a planetary nebula, and exposing its white-hot stellar core as a white dwarf star. A super-dense stellar corpse about the size of the Earth, which will slowly cool over the eons. Joyce says that, like Tiursa Minoris, the Sun too will become much bigger as it approaches death, consuming Mercury, Venus, and possibly the Earth in the process. She believes Tiursa Minoris is now entering one of the last remaining pulses of its life and expects to see it expand again in our lifetimes. The star will then become a white dwarf, possibly within the next few 100,000 years.
It was declining on a really short time scale, and something of that severity indicates a dynamical event. But until recently, we didn't really have the tools to model this, which is sort of where I came in.
When scientists talk about a declining radius, do they mean it's physically getting smaller?
Yeah, it's physically getting smaller, but the way that we actually detect the decline in radius is a bit more nuanced than looking at it directly. What they have been able to do is measure changes in basically interior pulsation periods, which it gets kind of physicsy at that level. But for all intents and purposes, we can say we've seen it decline significantly in its actual size in the past 30 years, pretty dramatically.
So these stars are sort of pulsating, and as they do so, they're pumping up a lot of carbon and things like that from deep inside, aren't they?
Yeah, so what I have been sort of deeming this is it's a thermonuclear hiccup. So it's encountering a lot of instability in its nuclear energy generation pathways. And what it's trying to do to compensate for this instability is increasing and decreasing rapidly in its size and brightness.
And this is where you come into the picture.
So until recently, we didn't have the sort of technology or the software or understanding to model these kinds of pulsations with the accuracy required. And within the last 3 years, some new tools and techniques have been developed to do this with higher accuracy. And I was able to sort of synthesize that and put those together and come up with models of this star that actually let us look at things as rapid as the pulses.
And what is that letting you do now? You're modeling these pulses. How does that help with the understanding of the star and what it's doing and where it's heading?
Well, because the evolution of the typical star, any star really, is happening over the course of billions of years, it's really difficult for our computers to model them at the precision of a few decades or a few centuries. And so what I was able to do was develop a technique to look at the evolution of stars on these really small timescales, which is, of course, what we're actually able to observe as humans.
So a star lives its life on the main sequence. A star like our sun. A star like our sun will,
right.
A star like our sun will live its life on the main sequence, fusing hydrogen in its core into helium. Now, eventually, it runs out of hydrogen in the core, and at that stage, it migrates off the main sequence onto what we call the red branch. And here it's fusing helium in its core into heavier elements, carbon and oxygen. And this star has moved beyond that stage. This is now moving on to the asymptotic giant branch. Tell me about that.
Yeah, so at this point, the Tierra Seminoris has undergone several phases of evolution that the sun has not yet encountered, which includes the main sequence, the subgiant branch, the red giant branch, and then sort of a duplicate of the red giant phase called the asymptotic giant branch phase. So by this point, it's exhausted all of its hydrogen and all of its helium, and because it's of a higher mass than the sun, it evolves more quickly, which means that it's exhausted these nuclear reserves in a much faster time than the sun has.
What will happen to it now? Is this big enough to undergo a core collapse, or is there not enough mass for that and it'll end up as a white dwarf like the sun, puffing off its outer layers?
So this is not large enough to undergo a supernova explosion. You need a star that's at least 8 times roughly the mass of the sun in order for that to happen. So this star, we expect, based on our modeling, will undergo a few more of these thermal pulses, roughly 5 to 10 is what we predict, and then sort of die off slowly into its white dwarf phase. And that is something that we expect the sun will undergo as well, but it's the thermal pulses in the case of the sun, there will likely be fewer, if there are any at all, and they will be less dramatic than the ones we're seeing in Tiumi.
And that's because this star started off about twice the mass of our sun.
Yeah, that's right.
And so what happens now? You're just going to check the accuracy of your model with the observations over the next 30 or so years, I guess.
So yeah, what we have here is a pretty unique opportunity to actually verify that our modeling is predictive on timescales of decades, which is incredible for evolutionary models because we're used to working in millions or billions of years. And over the next 30 years, we should have enough information to at least verify if the star is slowing down, which would confirm or support the hypothesis that we have made the correct assumptions about how stars evolve during thermal pulses.
Once all these thermal pulses stop and the star starts to, I guess the term I'm looking for is move into its white dwarf phase, so there'll be this white dwarf in the center, which is the superheated core of the star, and then the outer envelope will have pulsed off and it'll become a beautiful planetary nebula, which will then enrich the universe with sort of elements that life originates from.
Yeah, some of the most beautiful and captivating pictures in astronomy are of these dust shells surrounding dead stars, and that's in essence what the thermal pulses are forming. They're blowing off these layers of dust that will encircle the degenerate core radially, forming these shells that eventually migrate into the interstellar medium and provide the universe with the gas and dust particles it needs to form the basis of all planets and all life.
That's Dr. Meredith Joyce from the Australian National University, and this is Space Time. Hot on the heels of last week's spectacular first images from the James Webb Space Telescope, astronomers have now released stunning new Webb images of Jupiter and some of its moons, as well as its hard-to-see ring system. Also captured during the telescope's instrument test phase are new images and spectra of several asteroids. Astronomers say the new images demonstrate James Webb's ability to track solar system targets and produce images and spectra in unprecedented detail. The new Jovian images show distinct bands that encircle the planet, as well as the Great Red Spot, a giant anticyclone large enough to swallow the Earth. Also in shot is the Jovian ice moon Europa, the target of NASA's upcoming Europa Clipper mission. The moons Thebe and Matisse were also visible in the image, as was Jupiter's rarely seen ring system. Scientists are especially eager to see these images because they provide proof that James Webb will be able to observe satellites and rings near bright solar system objects such as Pluto, Saturn or Mars. They also want to use James Webb to explore the tantalizing question of whether or not they can see plumes of water and material spewing out from moons like Europa and Saturn's ice moon Enceladus, both of which have deep subsurface global liquid water oceans. Oceans which could harbour life. This is Space Time. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. The latest State of the Environment report is painting a dire picture of climate inaction in Australia. From coral bleaching to declining koala numbers, almost every environmental catalogue has deteriorated according to the 5-year study, which found Australia's environment is in poor shape and rapidly getting worse, with climate change, mining, pollution, invasive species, and habitat loss identified as key areas of concern. Addressing the National Press Club in Canberra, the Federal Environment Minister Tanya Plibersek described the findings as shocking. Over the past decade, Australia has seen more than 377 plant and animal species listed as threatened. That's more than any other continent. And continued land clearing is the cause. In fact, more than 6.1 million hectares of native forests have been cleared just since 1990 alone. And to make matters worse, we now have more introduced plant species in Australia than native ones. And just when you thought it couldn't possibly get any worse, we find the number of threatened native animal species has increased by 8% in the last 5 years alone. Average land temperatures have increased by 1.4 degrees Celsius since the early 20th century. And extreme events such as bushfires and floods are both becoming far more intense. For example, a single heatwave in 2018 killed some 23,000 flying foxes, and more than 1 million fish died in the 2018-2019 heatwave in the Murray-Darling River system. Then there was the Black Summer bushfires of 2019-2020. They alone burnt out some 8 million hectares of land, killing some 3 billion animals. The study shows that some 19 ecosystems in Australia are currently at risk of collapse. The report was handed to the former Morrison government at the beginning of last year, but they chose not to release it. Despite claims that the study was carried out by 30 independent scientists, critics of the report claim that many of the authors aren't scientists at all, but activists with no true scientific degrees. Hospitals are once again gearing up across Australia, with deaths from COVID-19 once again on the increase as the new highly contagious BA5 strain spreads. Health authorities are also seeing more cases that require ventilation in hospital as a result of the new variant, and demand for booster vaccinations is increasing around the country. It follows similar increases across Europe, where the increased transmission among older age groups especially is starting to translate into severe disease. COVID-related deaths have also increased in the Middle East, Southeast Asia, and across the Americas. The World Health Organization says the number of new cases globally has risen 18% in the last week alone. The latest statistics show that 1 in 30 people in the UK had the virus in the last week. That's an increase of 32% on the week before. So far, over 6.4 million people have been killed by the COVID-19 coronavirus. However, the World Health Organization says the true death toll is likely to be over 15 million, with some 570 million confirmed cases globally. America's Director of National Intelligence says the SARS-CoV-2 virus, which causes COVID-19, most likely originated in gain-of-function experiments at China's Wuhan Institute of Virology sometime before September 2019. Well, as the Northern Hemisphere continues to swelter under a heatwave summer, the United Kingdom has crossed the 40 degrees Celsius milestone for the first time in recorded history. Thermometers hit 40.3 degrees Celsius at Coningsby in Lincolnshire, while 33 other locations went past the UK's previous highest temperature of 38.7 degrees set back in 2019. The heatwave caused a huge surge in the number of wildfires across the UK, with thousands evacuated and many homes being lost. Scotland and Wales have also set new records, with the town of Charter Hall in the Scottish borders reaching 34.8 degrees Celsius, eclipsing the previous record of 32.9 degrees recorded in 2003. Meanwhile, the Welsh village of Hawarden in Flintshire set a new record of 37.1 degrees Celsius. That's around 100 on the old Fahrenheit scale. And of course, the heat waves have not just been localised in the UK. The rest of Europe are also reporting sweltering temperatures, leading to widespread wildfires and thousands of deaths across the continent. Professor Darren McAvoy from RMIT University in Melbourne says climate change science has long projected an increase in the frequency and intensity of extreme events, and the heat and fires currently devastating areas of Europe and North America can be considered a warning sign of things to come. He says what is considered extreme now is likely to become more commonplace in the near future. Strategic lawsuits against public participation, also known as SLAPP suits or intimidation lawsuits, are lawsuits intended to censor, intimidate and silence critics by burdening them with the cost of an expensive legal defence until they abandon their criticism or opposition. In a typical SLAPP suit, the plaintiff doesn't expect to win the case. But the plaintiff's goal is accomplished if the defendant is forced to succumb to fear, intimidation, mounting legal costs, or simple exhaustion, abandoning their criticism. And the reason we're talking about SLAPP suits is because they're becoming a popular legal tool among shonky pseudo-scientific practitioners. To protect freedom of speech, some jurisdictions have passed new anti-SLAPP suit laws, which often work by allowing a defendant to file a motion to strike or dismiss on the grounds that the case involves protected speech on a matter of public concern. The plaintiff then bears the burden of showing a probability that they will prevail. Now, if the plaintiff fails to meet their burden of proof, their claim is dismissed, and the plaintiff is required to pay penalties and costs for bringing the case. Tim Mendham from Australian Skeptics says, other than the Australian Capital Territory, there are no proper SLAPP suit laws in Australia, leaving the field wide open for snake oil salesmen and con artists to continue promoting their fake cancer cures and weight loss treatments until the law eventually catches up with them, which could take years, if ever.
He was sort of surfing Philippine health sites, being a GP himself, and he came across a Filipino naturopath who was making all sorts of strange claims, issues and things, and he started speaking about this naturopath and pointing out some of the, let's say, errors that she was making in her claims, including about her own qualifications and things like that. That didn't go down well with the naturopath, who was actually now living in America. She had been sort of had some issues in the Philippines herself, actually, with making claims that didn't go down well. So she decided to sue for damages, huge amounts of damages, hundreds of thousands of dollars she's claiming, plus, of course, wants him to take down all his videos and all sorts of stuff. Yeah, the usual thing. He's fighting that, trying to find the money to do this. And apparently this is what can happen nowadays. There's a situation called tourism libel, in which people can, because you've put something up online, someone in any other country can sue you, and they don't necessarily have to sue you in the country where you're from or where they're from. It used to be the case that people used to often go to the UK to raise a legal suit because that had traditionally large payouts for claimants. So they thought that was a good place. The UK's now cracked down on that, thankfully.
This reminds me very much of the Steve Novella case.
Yes. So Steve Novella of the Skeptics Guide to the Universe, who's also a neurologist professor at Yale, I think it is. They raised claims about someone in particular, and that they got hit heavily with a legal suit.
They won the case in the end. These are called SLAPP suits, and they're basically designed to make people who are speaking out against injustice shut up about it.
Yeah, that's right. I mean, the SLAPP stands for Strategic Lawsuit Against Public Participation. Now, the claims that the person might be making, I mean, the person who's being sued, the claims that they're making about the other person might very well be true, but there's a situation where you go in to see if there's a case. And the idea there is that it's just going to cost you a lot in legal fees and things like that. And basically, it's designed to shut you up even before you get to trial. And this happened in Australia too. Ken Harvey, who's a noted sort of health specialist and campaigner against AltMed, things like that, made a claim against a fellow who's notoriously criminal because he's been charged and jailed so many times of a diet product that was you basically put it on your tongue and you'll lose weight. And he raised that as being a shonky product, which it is. And this fellow sued him with this obvious SLAPP suit to try and just get him to shut up so he could keep selling the product while the court case, while this pre-trial was going on. He was having trouble finding the money to pay for this, so the Skeptics set up a grassroots campaign to raise money to cover his legal fees, which we did. And we've done similar things elsewhere.
There was another case in Germany, wasn't there?
That's right. Britt Hermes, who was an ex-naturopath, and suddenly found out how silly most of the stuff the naturopaths claiming are. And she made a comment about someone in America, she's in Germany, this person's in America, about their claims and especially about their situation with raising donations for a particular fund. She got sued. And Australia again, the Australian Skeptics again set up this grassroots campaign globally because she was going to get hit with huge amount. The trouble with Germany is you don't get necessarily large damages even if you win. That was quite a lot of money spent, about over 50,000 euros, I think, was spent on that. But we, through the global sceptical community, we managed to cover her fees. It's a situation that a number of practitioners of dodgy claims are using these days to try and shut people up and then continue to sell until it goes to court and they're found out to be sort of dodgy, and therefore it doesn't go any further, and the person, the victim who's being sued, claims damages and doesn't get much, especially if the person might disappear, as happened with the Ken Harvey case.
Slap suits are generally regarded as being the dregs of the industry. It's like lawyers who chase ambulances.
Yeah, yeah.
Is anything being done in the legal profession in this country to stop it?
Because the term is frivolous litigation. What's the term for that? That might be the term, actually. That people bring cases, and if they're frivolous, they just get thrown out of court. And that's probably what happens with most of these. But in the meantime,
it costs you money.
It costs you money. You're being intimidated. You're going under a great deal of stress. It can cause you real stress, real personal, health, financial, obviously stress. And you might end up, quote, winning, unquote, but you're losing because you lose all this money and that sort of thing, and everything that can affect you. And it's a damaging situation, this. So, yes, they are the sort of bottom feeders of the legal profession. But legally, you're entitled to bring a case, and what happens is that the legal system decides if your case is vexatious or if it's worthwhile. And most of these things turn out to be sort of pathetic cases and not worthwhile following up. And meanwhile, the pseudo practitioner has benefited. The ACT, the Australian Capital Territory, has done the protection of public participation, which is intended to a certain extent look after these sort of things, but it's about public interest as much as anything. A party starting or maintaining a proceeding against a defendant for an improper purpose may be ordered to pay a financial penalty. And actually, you cover costs, and that includes the court's costs.
That's Tim Mendham from Australian Skeptics. And that's the show for now. Spacetime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. Spacetime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the Spacetime store for a range of promotional merchandising goodies, or by becoming a Spacetime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more Spacetime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our Spacetime YouTube channel, and on Facebook, just go to facebook.com/Spacetime with Stuart Gary. And Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.